All right, we're going to do some 9.2 now. The first thing that I want to show you here in 9.2 isn't actually in 9.2. It's kind of a review from Calc 1, and that's something called separable differential equations. So we'll just do one example of this, just because this should be something that you've already seen before. So the easiest one that I can think of, let's say you have the derivative y prime is equal to x times y. Okay, something is a separable differential equation if you could rewrite that right-hand side into a function of only x times a function of only y, which is what we have here, right? And then what you'd want to do is you want to rewrite your y prime as that dy dx. Instead of thinking about that as the derivative, we're going to think about that as the ratio of the differentials. Then we want to get everything that has a y on the left-hand side with the dy, everything with an x on the right-hand side, and multiply the dx over. So we're going to rewrite it like this. We're going to divide that y over to the left-hand side, leave the dy there, and then we're going to leave the x alone, but multiply the dx over. Now what you want to do is integrate both sides. The integral of 1 over y dy is going to be the natural log of the absolute value of y. The integral of x dx is 1/2 x squared plus c. Don't forget that plus c. And then if I want to solve for the y, I would just take the e of both sides. So the e cancels out the natural log over here, but on the right-hand side, we'll write this as e to the 1/2 x squared plus c. And then you can even rewrite this a little bit. As e to the 1/2 x squared times e to the c. And then e to the c is just another constant, so we could rename that as a. So that a, and then we still have the e to the 1/2 x squared. So if you were to take this and plug it into this differential equation, it would work out. Okay, so that's a separable differential equation. This should be something that you guys have already seen from Calc 1. Now let's move on to a new type of differential equation that you probably have not seen before. This is something called a first order linear differential equation. So we've already talked about first order. First order means that we're only talking about the first derivative. Linear, though, on the other hand, linear means that you are going to have a single y term in your equation. The standard form of a linear differential equation looks like this. It's that derivative by itself plus some function which we label p of x times y, and that's going to be equal to a different function q of only x. So again, this is linear because it only has that one single y floating around. Or at least you could rewrite it so that it's a function of x times y, but we only have a y to the 1 power, that linear term there. Okay, so let's talk about how to solve these things. And it's going to take me a little bit to set this all up. So let's say you're given a differential equation in this standard form. What we're going to do is we're going to choose a function v of x such that it transforms the left-hand side into the derivative of the product v times y. Okay, and there's a special way or a certain way to do this, all right? And I'm going to show you how to do this. So before I show you how to find the v of x, let's at least see if we did find the v of x, how it would work. So i.e., what this top sentence up here is saying is that we're going to multiply that v of x onto what we already have on the left-hand side. So it's going to be that v of x times the derivative plus that p of x times v of x times y. All right, so this is the left-hand side of the equation, but we multiplied by v of x onto each of the two terms there. what I'm claiming is that we're going to choose this v of x in a certain way that this left-hand side will reduce down to be the derivative of v times y. You can kind of think of it like the product rule, right? It would be the first v derivative of the second y prime here, plus the second y times the derivative of v, which is going to be this p of x times v of x. So therefore, we get the following, right? Just kind of rewriting this thing a little bit. What we want to do is we want to solve this for v, or not solve it for v, sorry, solve it for y. So let's rewrite and kind of start back over. Therefore, starting over, if we have our differential equation dy dx plus p of x times y, and that's equal to q of x. So just our standard form differential equation. What we're going to do is first we're going to multiply by v. We haven't decided what v is yet, and we'll talk about that later. But let's say we did have a v. If we multiply that on v, we're going to have the v, the dy dx, plus here we're going to have the p, the v, and then the y. And on the right-hand side, we're going to have that q, and we're going to have the v. Keep in mind that all of these things are functions of x. Right? So these are all functions. Okay, what we're claiming, right, is that this left-hand side here, we could simplify down as the derivative of just v times y. And then if we do that by integrating both sides, when I integrate the left-hand side, all that's going to happen is the derivative cancels out. And then on the right-hand side, we're just going to take whatever the integral of q times v is, and then I can solve for my y by dividing the v over to the other side. All right. So the point of these last 4 or 5 lines here was just to show you that if we could rewrite the left-hand side as the derivative of the product, then I can get the y by itself. So now let's talk about how to find v. First off, this v of x has a name to it. So v of x is called the integrating factor. It's called the integrating factor because it's the thing that we multiply to be able to integrate. Okay, so to find it, this is some behind the scenes stuff. What we're going to do is let's just set the derivative of the product of v times y equal to what we want it to equal, which is that v, the derivative of y, plus p vy. This is the left-hand side of the differential equation after we multiply it by v. All right, we could rewrite this left-hand side. This is the derivative of a product. So we'll write that as a first derivative of the second plus the second derivative of the first, still equal to this over here. I'm going to rewrite this dy dx as just y prime. Now what we can do is we can subtract vy prime from both sides, and that just disappears. So we have the y v prime is equal to the p vy. Both of these have a y on there, so I can divide by y. And then if I want to solve this for v, this is a separable differential equation. So to solve that, we're going to divide the v over, and then rewrite v prime as dv dx. So it's going to have a dv here, but then we're going to multiply that dx over to the other side. Don't forget that p is a function of x, so it has x's floating around inside of it. Now we're just doing the separable thing, so we're going to do the integral of both sides. That left-hand side becomes the natural log of v. The right-hand side is whatever the integral of p of x dx is. We don't know because we don't know what the p is. If I then want to solve for v, I would take the e of both sides. This is now the formula for finding the integrating factor. Okay, so I've thrown a lot at you guys, I know, but this is kind of the setup. So let's look at steps. Given a first order linear differential equation. Step 1. If needed, rewrite in standard form. So not every example that you're going to be given is going to be written in standard form. Sometimes you may need to do some algebra to get it that way. Step 2, find the integrating factor. The integrating factor we get by taking e raised to the power of the integral of p of x dx, where p of x we get from the standard form. Okay. Next, multiply both sides of the differential equation by this integrating vector v. Rewrite the left-hand side as the derivative of v times y. Almost there. Integrate both sides. And then finally divide by v. Alright, so it seems like a lot of steps, but I promise you it's not too bad once we get into some examples. So I'm going to end this video, and then the part 2, we'll actually do a couple of examples.